This afternoon, we're explaining the more standard stationary faces for mechanical seals. We'll have on this side a big bore gland for a 3196 MT seal, which has the stationary face down in the base of the gland. On this side, we have the standard bore seal for the same pump. It's a smaller diameter, and it also has the place down at the bottom for the seal. Okay. Now we're going to explain a little bit about the different kinds of materials that the most common types of materials used for mechanical seals. Let's start at the least favorite and go to the best mechanical seal combinations. Okay. The standby has always been the ceramic, and that's carbon to ceramic. And this is a very good combination. It's very good for low pressures and low temperatures. However, it has a tendency to fracture if you get any kind of contact with the faces or the sleeve or anything else. It will fracture and crack really bad. So over the years, we've changed more in the industry to a tungsten carbide, which has a tendency not to do that. It will not break as bad. The only problem is it retains a lot of heat and can cause vapor pressuring and different things at the faces. It's a very good material, but it does cause problems. The very best is the silicon carbide, and it's, as you can see, is much less weight. It's very, very light material, and it dissipates heat very good. If you're looking at hardness, you're looking at the very hardest material right here next to diamond. Then you go to tungsten, and then ceramic is somewhere in between. Okay, it's very hard, but like I say, it's very fragile. Okay, so we've got a very good material here. It dissipates heat. It's got two different kinds. You've got reaction bonded, which is not as good from a chemical protection as the silicon, centered silicon. It will withstand more chemical products than this, and more acids especially than the reaction bonded. Okay, from a sizing standpoint, the cup mounted seats like this and this have a tendency to be oversized of the area that it goes into. So if we look at this right here, we're measuring 2.514. And when you put it down in this holder, it won't go down in the bottom unless you push it all the way down in there. Okay. So then if we're looking at tungsten or silicon, we're looking at it being loose in there, and it measuring without the O-ring, it's going to measure 2.845. Okay, so it will go down in here because this hole down here that this goes down into the seat area is 2.5 inches. Okay, now with the O-ring on it, same size, it goes in here like this, and with the O-ring, it fits the same size. It's the same OD as your cup seat. Just a second here. Now, 2.515. Okay, so you have the same size. It's just according to whether it's got an O-ring on it or a cup seat. We will explain more about materials as far as elastomers in the next video.